Hola! Welcome to this lesson video for special right triangles and their side ratios. So we're going to be able to find the missing side lengths of special right triangles by just knowing these ratios that we're going to talk about. The first one, I kind of got a little discovery exploration we want to work through, dealing with 45, 45, 90 triangles. Okay, so the directions say use the Pythagorean theorem to find the missing c value, which is the hypotenuse, and we're going to write our answers in simplest radical form. So if you remember the Pythagorean theorem, a squared plus b squared equals, c squared. Doesn't matter which legs you label as a and b, but we're going to end up having 1 squared plus 1 squared will equal c squared. And the sum of these squares, 1 squared is 1, so 1 plus 1 is 2 equals c squared. And so to get c by itself, I need to get rid of the square by taking the square root. And so my c is simply the square root of 2. Now can I reduce that radical at all, or is that simplest form? Square root of 2 is as low as it can go. So the hypotenuse here is a radical 2. Now the next one is the same triangle, 45, 45, 90, except they kicked up the measures of the leg. So now we've got 2 and 2. So when we think about the Pythagorean theorem, we're doing 2 squared plus 2 squared equals c squared. And so this is going to be 4 plus 4, which is 8. And so when I take the square root, I've got c equals the square root of 8, and I think I can reduce this radical 8. If I come over here to the side and do a factor tree, let's see, 2 and 4, 2 and 2. Since I'm dealing with a square root, I'm looking for pairs, and this means that a 2 comes outside, and this guy is left over, stays in the square root house. Okay, so this would be my c value, meaning that's the value of my hypotenuse. Okay. Whoops, we kind of lost it, but this is a 3 down here. So same thing again, just kicked up the side measures, still a 45, 45, 90. So Pythagorean theorem is looking for 3 squared plus 3 squared, which is, let's see, 9 plus 9, which would be 18. So when I take the square root, looks like I'm needing to do a factor tree of 18 because I end up with the square root of 18. So let me over to the side. Let's see, let's go 2 and 9. And 3 and 3. Look, there's a pair, just like I need. So the 3 comes out. This guy stays in. So this would be my c value, which is my hypotenuse. Now, the next question asks us for what pattern did we notice as we did this? Problem to problem. So let me scroll back to the first one again. When our side measures were 1, our hypotenuse was radical 2. When our side measures were 2, our hypotenuse was 2 radical 2. And when our side measures were 3, our hypotenuse was 3 radical 2. So what pattern do you notice? I'll give you a second to think about it. 2 things I notice. First of all, each of them had a radical 2 in the answer. Okay? But then also, notice the side measure. The side legs are 3 here. What's the number outside? The side measures are 2 here. What's the number outside? The side measures are 1. What's the number understood to be outside? A 1. Okay? So the pattern that I notice, if I just kind of draw my own arbitrary 45, 45, 90, and if I say the sides are x, well, I know the hypotenuse is going to have radical 2. And what number is going to end up being pulled out front? Well, whatever the side measures were. Okay, so this is kind of a generic form, if you will, of a 45, 45, 90 side ratios. Now, let's see. How can I use that to help me find the side measures if I know that the hypotenuse is 4? Okay. So here's where folks kind of get confused. If this side is x, that means this side is x, okay? And if I'm thinking about the ratios we just talked about, that means that the hypotenuse is x radical 2. But I was given the exact value of the hypotenuse. I know that the hypotenuse is 4. So you see how I kind of did this equal sign? It's exactly what I do. In the generic kind of world, the hypotenuse measures x radical 2. But I know that in this case, x radical 2 is literally equivalent to 4. So I make myself a little equation, and I just need to solve for x. So x and radical 2 are being multiplied, so to break that multiplication, I would need to divide by square root of 2. So then that way those are gone. And here's what I'm left with. X equals 4 over square root of 2. But if you've taken any sort of algebra class, there we go, level algebra class, you'll know that this is not acceptable. You cannot have a radical in your denominator, so we need to rationalize. And we do that by doing this like special fraction kind of thing where we multiply top and bottom by square root of 2. Okay, so on the top, 4 times radical 2, well, it's just 4 radical 2. Since the 2's in and the 4's out, there's no way I can get an 8, so that's what I'm stuck with. Radical 2 times radical 2, that would be square root of 4, which square root of 4 is just 2, okay? And then these outside numbers, I want to think about reducing. 4 divided by 2 reduces to a 2, okay? Now, we just did a whole bunch of work here, and what does this even mean? Remember that this number is the value of x, okay? What we just solved for is x. Now, in respect to my picture, what does that mean? That means that this leg is 2 radical 2, and this leg is 2 radical 2, okay? And then the hypotenuse is what I was given. I'm kind of stuck with it. It's just simply 4, okay? So as long as we have one side, we're able to find the other two when we have these special right triangles using these side ratios. So I only showed you a 45-45 so far, which is the side ratios we just figured out ourselves. I didn't want to make you do another exploration with a 30-60-90, so I'm just giving it to you here. The side opposite the 30-degree angle is your plain old x side. Okay, that's the short leg of the 30-60-90. The longer leg will be equivalent to x radical 3, and then the hypotenuse will be just double whatever the x value is. So let me show you how that works since we haven't done a 30-60-90 yet. So the side that I'm given here in picture 1 is the side that's opposite of 30, which is equivalent to this side. So that means x is 7. So this is an easy one. I know x. I don't have to solve for it. Okay, I'm just going to plug in 7 for my x. So in the long side, it's supposed to be x radical 3, but I know that x is 7, so it's simply going to be 7 radical 3. The hypotenuse is twice of x, so since x is 7, double 7, my hypotenuse is 14, and that's it. That's all I'm looking for. Okay, so question 2. If I give you this side of the 45-45-90, so I give you a leg, that means you know an x value, and the other leg is the same, so the other leg has to measure 3, and the hypotenuse is whatever x was times radical 2. So x was 3, so 3 times radical 2. And there are my side measures that we're missing. So these are easy when you know x. I like these a lot. But I do want to show you one that's a little more complicated. Let's see. All of those ones are fairly easy. Let's do number 5. No, I'm going to do number 6, because number 5 is like that one we did. I can show you. Number 5 is a lot like this guy, where you know the hypotenuse and you set it equal to that x radical 2. Let's do a different one. Let's do number 6 here. The side opposite of 30 is the x side, which, man, that's not what I'm given. I'm given the long leg, which is equivalent to x radical 3. Okay, so x radical 3 is the side I'm working with, and I know that this equates to a 27. Okay, so it's kind of like the one I just showed you, except instead of a radical 2, we got a radical 3. X and radical 3 are multiplied because you know I'm trying to get x by itself. So to break that multiplication, I'm going to divide by square root of 3. Okay, so it's going to be 27 divided by square root of 3. But again, like we've talked about, this is not proper. We need to rationalize. Get rid of that square root that's at the bottom by multiplying by square root of 3 over square root of 3. So this is going to equate to, let's see, 27 radical 3 divided by, radical 3 times radical 3 is radical 9, which is just a 3. Square root of 9 is 3. So then those reduce to 27 divided by 3. Those reduce to 9, square root of 3. Okay, but again, remember what this means. This number represents x. So as far as the picture, that means that this short leg, which is just x, is simply 9 radical 3. And based on, the generic sides, the one that I'm missing, the hypotenuse, was twice of x. So I need twice of this number that I got for x, which, be careful, twice of 9 is 18. Your radical 3 doesn't change. Okay? So these numbers in the black, I'll circle them. That's the side measure, that's the short leg, that's the hypotenuse. Okay, so those are the 3 sides of the triangle. So if you've got your trig packet, the rest of this page is for you to finish. That's the assignment. I believe that's it for my examples. Yeah, so what's coming up next is creating the unit circle. So these are 3 more videos you might want to check out. But like I said, that's it for me on this one. So keep learning, have fun, and I'll see you next time.